Having looked at the importance of reference points in detecting movement, let's consider now how to calculate motion and determine an object's rate of speed. Motion. Indeed, objects in motion are all around us, at all times, and in all shapes and sizes. Basically, motion occurs when an object changes position. That is, goes from one place to another during a certain amount of time. But remember, the movement of the object is always described in relation to a reference point. Think for a moment. What device do we commonly use to capture an object in motion? Still cameras can enable us to freeze the image of an object in motion. When you use a still camera, a split second or segment of motion may be captured on an image or photograph. This happens when the shutter on a camera exposes light for only a fraction of a second. If the exposure is not fast enough, however, the image is a blur. Such high-speed photography has become very important in science and technology as experts study moving subjects in the physical world.
One of the factors we consider when an object is in motion is the rate at which it travels, which is more commonly known as its speed. Scientists calculate such speed for objects in motion in terms of kilometers per hour or meters per second. Physicists tell us that any object changing position has speed, not just things like human beings or vehicles, but the wind, ocean currents, even our planet Earth, which orbits the Sun at an average speed of 30 kilometers per second. To calculate the speed of a moving object, we need to consider several factors. For example, this race car takes 10 seconds to travel a distance of 600 meters. What do you think the speed of the car is during this 10-second interval? Make an estimate, and let's see if you're correct. The correct answer is 60 meters per second. If you know the formula or equation that scientists use to determine speed, the answer is quite easy. The equation for speed is speed equals distance divided by time. And the international standard used by scientists for this equation calls for distance stated in meters and time in seconds.
When discussing motion, of course, distance is the length between two places. So in this case, using the equation for speed, we can solve the problem by dividing the distance, that is, 600 meters, by the time, 10 seconds, with the result that the speed of this car during the 10-second interval is 60 meters per second. This formula, speed equals distance divided by time, is used to calculate speed when an object travels at a constant speed all the time.
But consider this factor. Do objects travel constantly at the same speed? What happens, for instance, when a race car approaches a curve? In all likelihood, the race car will slow down. In fact, objects usually do not travel continually at a constant speed. An airplane, for example, adjusts speed when it takes off, lands, or experiences turbulence in the air. Most objects experience a change in speed when they start up and when they slow down to maneuver or come to a halt. How then can we calculate the speed of objects in motion if they usually don't move at the same speed during the time they're observed? Since objects usually move at different speeds, scientists have developed an equation taking this into consideration, with the outcome called the average speed. The equation for average speed is the total distance traveled divided by the total time taken to cover that distance. Let's suppose your family starts on a trip to visit relatives, and you take 6 hours to travel from your home at point A to your aunt's home at point B, a distance of 420 kilometers. Take a moment now to calculate the average speed of your vehicle. To get the answer, you divide the total distance, 420 kilometers, by the total time, 6 hours, with the answer, the average speed, being 70 kilometers per hour.